Hi guys, welcome to the second part of this video. There's a brief thing we're going to talk about in terms of perpendicular lines before we jump into interpreting geometric diagrams. So perpendicular lines, what does that term mean anyway? Perpendicular lines intersect to form four right angles. Lines that are perpendicular to one another intersect at a 90-degree angle, okay? Form a right angle. So if this line is perpendicular to that line, it forms a right angle. How do we know that they in fact form four right angles? Well, what do we know about lines when they cross? Don't they form two pairs of vertical angles? And aren't the vertical angles congruent to one another? So if this guy's 90, then this vertical angle down here is 90 degrees. Okay. Now, his friend over here this is not a vertical angle, but these angles form a linear pair because that is a straight line, right? So these two angles have to be supplementary. That means they have to add up to 180. And if this is 90, well, this guy's got to be 90. And then we could say, well, hold on, this guy is vertical to this guy, and vertical angles are congruent. So you can quickly prove that two lines intersecting, if they're perpendicular, they form four right angles. So they intersect to form congruent adjacent angles, and segments and rays can be perpendicular to lines or other line segments and rays. Okay, so we might say that we might have a line here, and then you might have a ray coming off of it. And you might say that ray is perpendicular to the line. It just means it forms a 90-degree angle. And of course, our right angle symbol is here, but you're also going to see it written if in a word problem. You might see it written as describing this diagram. This says that line AD is perpendicular to line CB. Line AD is perpendicular to line CB. So when you see that symbol, that upside down T, read that as is perpendicular to. Okay? Is perpendicular to. Good, let's try some examples. Could we find X and Y so that line KO and line HM are perpendicular? Okay, so here's line KO, here's line HM, and we want them to be perpendicular. What would have to be true? If they're perpendicular, that would have to be a right angle, as would this, right? So could we find X and Y so that that condition would be true? What do you want to go after first, X or Y? Let's take them in alphabetical order. If this is 90 degrees, these two angles over here, you'll notice these expressions only contain X's. So I could come up with an equation in one variable here that I could solve. If these two angles add to 90, those are complementary angles. We can say that 9x plus 3x plus 6 must equal what? Must equal 90, right? And we can combine some like terms here and solve this. 9x and 3x is 12x plus 6 equals 90. I can subtract 6 from both sides, right? And I'll get 12x equals 84. And I'll divide both sides by 12. And I get x equals 7. Okay, good. All right, so if x equals 7, that would satisfy, that would make KO and HM perpendicular. What value would y have to have in order for this to be true, for these lines to be perpendicular? Well, this whole angle has to be 90. That means 3y plus 6 must equal 90, right? And could I go ahead and subtract 6 from both sides? Then I get 3y equals 84. Okay. And can I divide both sides by 3 here? And I'm going to get y equals, what is that going to be, 28? I think that's right. I'm going to check my math on that. You guys trust me? Oh, my calculator's dead. You're going to have to trust me on that one. All right, here could we find x so that AD and CE are perpendicular? great place to pause the video if you want to try this one yourself and see if you got the hang of it. If these two lines are going to be perpendicular, then all four of these angles are going to have to be right angles, right? Including this one, okay? Where we have these two angles that are represented by these expressions, 4x and 5x, okay? So that means these angles have to be complementary. They have to add up to 90. So 4x plus 5x must equal 90, right? So we get 9x equals 90. And how would we solve that for x? We'll divide both sides by 9. We get x equals 10. Good. All right, here's perhaps one of the most important concepts in the whole class, because we're going to be reading these diagrams all year long, and we got to know what we can and cannot assume when we take a look at a diagram. Over here on the left, we have things that can be assumed, and then we're going to talk about things over here on the right that cannot be assumed from these diagrams. Okay, we can assume that all points shown are coplanar. They all lie in the same plane, so we're not going to be messing around with any. If point J was way up here, we might say that therefore HJ is much longer than GH or something like that. We're not going to mess around with that stuff. We're dealing with two-dimensional geometry here. So we can assume our diagrams all lie in the same plane, the plane of the paper. We can assume in this diagram that G, H, and J are collinear, okay? We can assume they all lie on the same line, and we don't have to think, oh, possibly this could be a 179-degree angle or a 181-degree angle. No, they're not going to try to be that subtle. If you see a diagram like this, that's a straight line. G, H, and J are collinear. We can assume that rays HM, HL, and HK and line GJ intersect at H, okay? We can assume that these rays here all intersect at point H and that GJ passes through it, okay? There's not some tiny virtual distance here between H and the vertex of this angle that causes these angles to be non-adjacent or anything. No, we can assume that they all intersect at that point. We can assume that H is between G and J, okay? In other words, it's collinear and it lies on that line between those points. We can assume that L is in the interior of MHK. Okay, so here's angle MHK, and we can assume that L is in the interior, not in the exterior, okay? So we can work with that idea. We can assume that angle GHM and MHL are adjacent angles. In other words, they share a common vertex, they share a common side, and they have no interior points in common. They don't overlap each other. We can assume that GHL and LHJ form a linear pair. This follows logically from the fact that GH and J are collinear and that all of these rays intersect at point H. We can definitely conclude, therefore, that we've got a linear pair there. And by the way, there's other linear pairs hiding in here as well. We can assume that angle JHK and KHG are supplementary. Again, that's another linear pair. So yes, we can assume that they're supplementary. Okay, what can we not assume from this diagram? Okay, we cannot assume that HM and HL are perpendicular. Okay, we can't assume that ray HM is perpendicular to ray HL. Maybe it's close. Maybe you're even tempted to put your protractor on it. Don't bother. Even if you can measure it and you see that it's 90, you can't assume it unless we are specifically told. How would we be told? We'd be given a mark, like it's 90 degrees. Or we'd be given the words. We would have this given in a problem. If none of that is given, you can't assume it. We cannot assume that any of these angles are congruent. We cannot assume that JHK is congruent to GHM. They look like it. Even if I pulled out my protractor and I measured them and I found they had the same measure, I can't assume that they're congruent, okay? Sometimes things are drawn not to scale. And don't forget, all measurements contain error, okay? So unless they tell us specifically, By doing that, that would tell us that they're congruent. But unless they do that on a sketch or they tell us otherwise in the problem, we can't assume that those angles are congruent. Likewise, we can't assume that JHK and KHL are congruent. You might not have suspected that one. Or KHL and LHM, we can't assume they're congruent either. Likewise, the lengths of segments. We can't assume that GH is congruent to HJ. GH and HJ look like they might be the same length, but there's nothing on this sketch that tells me they are. If they gave me those slashes, I'd say, I know those are congruent. But without that information, we cannot assume it, okay? Likewise, HJ and HK, I can't assume that those segments are congruent, or HK and HL, or HL and HG. None of those things can be assumed from this diagram, okay? But all of these things we can assume when we're interpreting them. Let's try a couple of examples. Here, could we determine whether the following statement could be justified from the figure below? Could we assume it from just this information? Could we assume that angle VYT equals 90? VYT. Okay. Can I assume that? Now, on the one hand, you might say, Mr. Rogers, it's not marked. There isn't this nice right angle symbol here, so I can't assume it. But is there other information given in the problem that we could rely on and then extend to tell us something about angle VYT? Okay, I do know I can assume that X, Y, and T are collinear. And V and Y are on this line. And that means that XT and YV are perpendicular lines. Okay? And from that, I can conclude that this must be a right angle as well, right? Because perpendicular lines form adjacent congruent angles. Okay, you could also say if that's 90 and this is a straight line, then these angles have to be supplementary. So they'd have to be 90 and 90. So even though it's not specifically marked, from the other information that is marked, I can conclude that yes, the measure of angle VYT is 90. Could I determine whether the following statement can be justified from the figure below? Explain. Could I assume that angle TYW, maybe I'm going to highlight this one so that we can see it. TYW, that's this angle right here, TYW. Could I assume that that angle and TYU are supplementary? Okay. Is there information here that tells me that I can assume that these are supplementary? One thing I can rely on is the fact that U, Y, and W are collinear. Okay. I can assume that. That was one of the things that was on the left side of our things you can assume diagram, right? And the fact that they're collinear tells me that this angle's 180, and that means this angle's 180. And therefore, these adjacent angles must form a linear pair, and therefore they must be supplementary. So, yes, I can assume that from this diagram. How about this one? Can I determine if, from this diagram, that angle VYW and angle TYS are adjacent angles? Angle VYW and angle TYS. Okay, well, adjacent angles. Hold on, what was that definition? They've got to share a common vertex, which they do. You can see that middle letter. But they also have to share a common side. So how could VYW and TYS be adjacent? They have all this space in between them, okay? And they don't share, so they don't share a common side. Not only can I not assume that they're adjacent, I can assume that they're not adjacent. I can definitely tell they are not adjacent angles. Okay, how about this one? Could we determine this, whether the statement, the measure of angle XAY equals 90 from this figure, XAY? Can I assume that from this figure? Boy, they sure look like it. don't reach for that protractor. Don't reach for that protractor, okay? You might even measure it and find they're 90. But is there information that's given here or in this sketch that would be enough to rely on to say that this is 90 degrees? I really don't have that information, do I? I'm going to say no. What would I need? I need to know, I can assume that T, A, and Y are collinear, and I can even assume that S, A, and X are collinear. But I don't have anything else that tells me whether they intersect at 90 degrees or 91 or 89. I really don't know. If you told me that, then I could do it. I'd be all set. I'd say, oh, vertical angles, we're good. Or if instead you had told me that this angle was 90, I could say, well, they form a linear pair, and therefore this must be 90 as well. But without one of those pieces of information, I cannot assume that that is a 90-degree angle. All right, how about this one? Could I determine whether the statement TAU is complementary to UAY? Is that something I can assume here? TAU, complementary to UAY. Okay. What do you think? TAU, TAY, they're collinear. I could assume they're supplementary, right? I think it's a trick question. But I can't assume they're complementary, right? In fact, I can pretty much be confident that they're not, because the fact that I can assume T, A, and Y are collinear. T, A, U, and U, A, Y, I can go ahead and assume that they're supplementary. And if they're supplementary, they're definitely not complementary. They can't be both, right? All right, last problem here, guys. Could we determine whether the statement UAX, angle UAX, is adjacent to angle UXA? Could we assume that from this figure? Well, let's look at UAX. UAX is right here. It has a vertex at A. See that? Vertex is A. It's the middle letter. What's the vertex of UXA? It's angle X. Okay. If two angles don't share the same vertex, they can't possibly be adjacent angles, can they? They can't be next to each other. They can't meet all those other, even if they meet all those other conditions, they can't be if they don't share a common vertex. They've got to share a common vertex and a common side and have no interior points in common. So I'm going to say no. We cannot assume that. In fact, we could state certainly that they are not adjacent angles for this. Okay, guys, I hope you found that helpful. Feel free to go back and look at that sheet again. That is in your key concepts, which I posted on Google Classroom, which hopefully will be helpful for you to refer to if you're looking at diagrams and you're not sure what you can and can't assume. Hope you guys found that helpful, and I look forward to doing some problems on this stuff with you in class.